Imagine you're sitting in a courtroom. The expert witness takes the stand, points directly at the defendant, and swears under oath that the fingerprint recovered at the crime scene is a 100% match. Boom! It's the ultimate forensic mic drop, right? For over a century, fingerprint identification has been the undisputed gold standard of criminal justice. We've been conditioned by history, by the courts, and honestly by popular culture to believe that our fingerprints are an entirely infallible, uniquely perfect signature of human identity. But what happens when the absolute certainty of that science collides head-on with real-world failure? Well, in this explainer, we're going to investigate the methodology, the science, and the surprisingly human fallibility behind forensic fingerprint identification. So, can a perfect FBI fingerprint match be entirely wrong? Just let that sink in for a second. We've all seen the crime shows, right? The computer screen flashes match found in big green letters, and the case is instantly closed. But out here in the real world of investigative criminology, the answer to this question isn't just a theoretical maybe, it's a highly documented reality, and it raises a genuinely terrifying possibility for anyone stepping into a courtroom that the ultimate forensic tool, the very one we rely on to lock away dangerous criminals or clear the innocent, might actually have a fatal human flaw. To understand how this works, we have to look at the 2004 Madrid bombing. This case brilliantly and tragically illustrates exactly what happens when that flaw is exposed to the world. Following a devastating terrorist bombing in Madrid, Spain, the FBI found a latent fingerprint on a bag of detonators. They matched it definitively to an American lawyer named Brandon Mayfield, and this wasn't just a quick glance. Multiple top-tier FBI experts verified this match. It was considered absolute, indisputable proof. There was just one massive, glaring problem. Mayfield had never even been to Spain. He didn't even hold a valid passport, and Spanish authorities later proved, without a doubt, that the print actually belonged to an entirely different person, an Algerian national. The FBI's perfect match was completely wrong. This wasn't some Hollywood script. This was a shocking, real-world failure that shook the entire forensic community to its core. So how does something like this actually happen?
Section 1. The crime scene and the lab.
Before a fingerprint ever makes it into a courtroom as evidence, its validity has to be established through a highly clinical investigative process. And to understand that process, we first have to understand the biology. Fingerprints are actually formed while we're still in the womb, specifically between weeks 10 and 16 of gestation. They're shaped by a complex mix of genetics and totally random factors in the intrauterine environment. When you break it down, human fingerprints fall into three classifiable patterns. You've got loops, which make up about 65% of all prints, whorls at 30%, and arches, representing just a tiny 5%. Now, while it's widely accepted that these patterns are persistent and unique, even identical twins have slightly different prints, here is a crucial scientific detail you need to keep in mind. This absolute uniqueness has actually never been mathematically proven.
And out in the field, at a messy, chaotic crime scene, investigators are almost never finding a perfect, pristine print like you'd press onto an ink pad. Instead, they usually find what we call latent prints. These are completely invisible impressions left behind by the natural sweat and oils from human skin. To even see them, investigators have to use chemical or physical enhancements. We're talking about meticulously dusting the scene with black, magnetic, or fluorescent powders, or using a process called cyanoacrylate fuming, which is essentially using superglue vapors just to make the invisible visible. It is an incredibly delicate and fragile collection process.
Once that fragile print is successfully lifted from the scene, it goes straight to the lab. This is where the dominant global forensic methodology takes over. It's called ACE-V. Step 1 is analysis, where the examiner looks at the quality of the latent print to see if there's even enough detail to work with in the first place. Step 2 is comparison, which is doing a methodical side-by-side with a known suspect's print. Step 3 is evaluation, where the examiner firmly concludes if it's an identification, an exclusion, or if it's just inconclusive. And finally, step 4 is verification, where a second independent examiner reviews the initial conclusion. It sounds incredibly methodical, safe, and pretty much foolproof, doesn't it? Well, the crucial question here is, what exactly are these experts comparing during that second step? They're looking under a microscope for highly specific ridge characteristics, known as minutia points. Things like ridge endings, where a line just simply stops, bifurcations, where a ridge splits off into a Y shape, or little dots and islands. The examiner meticulously maps out these tiny details on the crime scene print and checks to see if they line up geometrically with the suspect's print. But remember that little seed of doubt we planted a minute ago? The fact that fingerprint uniqueness has never actually been mathematically proven? That brings us to a rather chilling realization about how these minutia points are legally used in the United States. 0. There is exactly 0 universal standard number of matching points required for a fingerprint identification in the US. None. Some countries around the world require 12 matching points. Others might require up to 16. But in the United States, a match relies entirely on the subjective judgment of the human examiner. There is no fixed scientific threshold you have to cross. If the expert examiner feels there's enough detail to call it a definitive match, it goes down as a match.
Section 2, the human element and the flaws.
And this brings us right to the most vulnerable part of this entire investigative machine. We've been led to believe this is an exact science, driven by cold, hard data and high-tech computers. But the reality is far more subjective, and because of that, it's far more prone to real-world error. We actually need to shatter a massive Hollywood myth right now. You know AFIS, right? The Automated Fingerprint Identification System? It's the supercomputer on every crime show that rapidly scans millions of records and spits out a definitive match with a loud, dramatic beep. Well, AFIS does not make final identifications. Human examiners do. AFIS is essentially just a highly advanced search engine. It searches massive databases and provides a ranked list of possible similar-looking matches. But the final, life-altering decision of whether it is an actual match, that is left entirely to human judgment. And humans, no matter how well-trained or well-intentioned they might be, make mistakes. Here are the documented ways fingerprint identifications routinely fail in the real world. First, poor quality prints. If a print is smudged, partial, or degraded by heat and moisture, the examiner is essentially guessing at the missing pieces. Then you have similar pattern structures. Sometimes completely different people just happen to have incredibly similar ridge flows, which can easily confuse the naked eye. Then there's straightforward human error. Examiners get exhausted, they might lack proper rigorous training, or they face immense pressure from detectives to just close a case. And finally, there's over-reliance in court, where juries just automatically assume the evidence is absolutely infallible. But out of all of these, there is one specific flaw that is perhaps the most insidious threat to justice. It's called contextual bias. This happens when an examiner's conclusion is unconsciously influenced by knowing outside case details or knowing the suspect's identity. Imagine an examiner is handed a marginal, blurry, really tough to read fingerprint, and the detective standing over their shoulder says, "Look, we know this guy committed the murder, we just need this print to match so we can lock him up." Studies have repeatedly proven that this outside information can unconsciously sway an expert's supposedly objective evaluation, leading them to see a match that simply isn't there. And it was this exact cognitive bias that played a massive role in blinding those top FBI experts in the Brandon Mayfield case. Section 3. The ultimate comparison. Fingerprints versus DNA. So, if fingerprint analysis is this subjective and this vulnerable to human bias, how does it stack up against modern forensic science? Let's put this into perspective by comparing it to DNA evidence. When we look at the statistical model, DNA evidence is incredibly strong and probabilistic, meaning we can calculate the exact mathematical odds of a random match. Fingerprints? The statistical model is surprisingly weak and highly subjective. The error rate for DNA is a well-established, known quantity. For fingerprints, it's very limited. In fact, for decades, some experts actually went into court and claimed a zero error rate, which is scientifically impossible. Automation for DNA is highly advanced, whereas for fingerprints, it's only partial. Yet look closely at that final row on the board. The court reliability for both is considered high to very high. Juries today still weigh fingerprint evidence with nearly the exact same absolute trust as DNA, despite this massive gap in their scientific foundations. Because of this gap, the scientific and legal communities are finally waking up, and we're seeing some serious escalating pushback. First, you have the Daubert standard in the US, which now legally requires scientific validity and reliability for expert testimony. This has opened the door for defense lawyers to aggressively challenge fingerprint evidence in court. Then, there was a massive 2009 report by the National Academy of Sciences that severely criticized the field's lack of standardization. And followed up in 2016, the PCAST report demanded empirical validation and completely rejected the forensic community's long-standing claim of a zero error rate. This intense legal and scientific scrutiny is forcing some much-needed reform across the criminal justice system, driving home a vital foundational point. Future advancements must focus on standardization, transparency, and scientific validation to ensure accuracy and prevent wrongful convictions. And we're seeing changes. Today, progressive forensic labs are actually implementing blind verification procedures, where the second verifying examiner has absolutely no idea what the first examiner concluded. They're also actively limiting the contextual case information given to examiners to prevent that dangerous cognitive bias we talked about. And finally, they're actively funding research into the probabilistic mathematical models that the field of fingerprinting has lacked for over a century.
Section 4, a powerful but imperfect tool. So, where does this leave us? Well, fingerprint analysis is not going away, nor should it. It has solved countless crimes, brought closure to victims, and it remains an absolutely critical tool for criminal justice worldwide. But the illusion of its total infallibility is a profound danger to the system. We absolutely must respect the science, but we also have to acknowledge the inherent human flaws within it to ensure that true, undeniable justice is served. The question is, knowing everything we know now, would you still trust a perfect match with your life? Comment your thoughts on this video. Also, subscribe to us to see more videos like this in the future. See you in the next video.